Hi everyone, welcome to Access MSc Labs. Today we're going to be talking and doing a couple demos regarding refraction of light. As we talked about in the Zoom lecture last weekend, we are going to be showing the difference between the refractive index in air and water. What that means basically is that at the interface of air and water, for example, in a glass of water like this, you'll be able to see an element of bending of light.
As we discussed in class, light travels at different speed in different mediums. It travels much faster in air than it does in water. So this is a very simple demo we can perform to just see this effect. All you need is an empty glass, some water, and any straight object. So in air, light travels at a constant speed. So if I put this pencil into the glass, you'll see it's a straight line. But since light travels at different speeds in air and water, if I put this straw into the cup, you'll see that at the interface, there will be some bending. It will no longer be in a straight line, and that is due to the bending of light that occurs in water.
Hi guys, now we're going to be doing another demo that uses the same property regarding the refraction of light and the differences between water and air. For this demo, all you need is again a glass of water and a sheet of paper with something drawn on it. We've drawn an arrow. So, as some of you may have noticed just from drinking water, I know I used to think about this when I was a kid, was that when you take an arrow and you put it behind a glass, it's the same. However, when you move it down below to be under the water level, the arrow actually flips. This works if you go from this way as well. So this property actually has to do with refraction of light and the water in the glass creating a lens.
There are many interesting things you can do with the refractive index, and we encourage you to actually try this out yourself at your house and just play around with the different things you can do with just a glass of water and any drawing.
Hi guys, for the third and final demo, we're going to be showing the property of a calcite crystal, which also has a special optical property. Instead of having one refractive index like water, it actually has two. So light bends into two different paths inside this crystal. To show this property, we're going to be using a polarization filter. Some of you may be familiar with polarization because it's in a lot of our sunglasses. For this demo, all you need is a piece of paper with a little mark on it and a $5 calcite crystal, which you can order off Amazon. However, watching it will be fine. You can almost already see my finger looks like there are two images of it. And when you place the calcite crystal over your image, which we've drawn a little heart, you can see that there are two hearts that are being shown.
This effect is known as birefringence. If we take a closer look, we can see that when we spin the crystal, the two images spin as well. From that we can infer that the refractive index of the crystal depends on the orientation. Although the crystal has two refractive indices, there's only one light coming in, so why do we see two images? Well, the answer is because there isn't only one type of light coming in. Light actually has different polarizations. To think of polarization, we cannot think back to what a vector is. Any vector can be broken down into an x and y component. Similarly, light is broken down into a horizontal polarization and a vertical polarization. So if I place this polarization filter, what this filter does is that it only allows one of the components through, either the horizontal or the vertical component of light. So if I spin the polarization filter to match the orientation of the crystal, we can see that now only one image is coming through. And that's because only the horizontal component of light is coming through. But if I then spin the polarization filter exactly 90 degrees so that only the vertical component comes through, we can see that the image should transition. And that is exactly what we observe in this crystal.
Do it a little faster.
And now we can just play around with it to make it jump.
Theoretically, if we had a larger, much more pure block of calcite, if we shine a laser through the block, you would be able to see exactly two beams showing the two refractive indices. However, this is a much cheaper crystal than a pure block of calcite, so there are too many defects to actually see that effect. But you can imagine this beam splitting into two beams like the water bent the pencil. Thank you guys for watching. We really appreciate you tuning in. We hope you learned something, and we really encourage you to try these at home. They're really easy. You can play around with them. And if you have any questions, don't hesitate to ask. You can either email us or ask us in class next Saturday. See you guys soon.